let's start in your notebook first. We're going to do the same thing, but maybe we could be a little bit more accurate if we used a different shape. Today we're going to try some trapezoids. Okay? If we use trapezoids instead, then we'll still be all under the curve, but it won't be so rigid like those rectangles were. Okay? We give ourselves a little bit more accuracy by using a trapezoid. For example, we're going to make a trapezoid like this. So these are the trapezoids. Do you see what I'm talking about here? Okay, so we're going to get a little bit more accurate. There you go. But how do you find the area of a trapezoid?
That's a good question.
Okay, I heard a bunch of different versions. So 1/2 times the height times the sum of the bases. If you were one of those people who couldn't roll this off of your tongue, maybe you should write it down. Could come in handy today. So the process we take isn't really going to be that much different. We're just finding the area of trapezoids instead of rectangles to try to get a little bit better accuracy. So we're still going to have to determine the number of trapezoids. All right. Typically that's going to be given to you N. All right. N is the number of trapezoids that we are going to use. But trapezoids don't have a width, all right? Before we use delta x as our width of the rectangle, well, if we have trapezoids that all look like this, what is delta x going to refer to in that trapezoid? The bases are the two parallel sides. So delta x is referring to our height. So we'll find delta x, and that gives us the height of each of our trapezoids. Similar to how we did our rectangles for our bases. So this is what we would consider to be base 1. This is going to be base 2. Since this is fitting underneath of our curve, the function value is going to determine the bases for each of our trapezoids. Then we'll use that information to find the area and add all the areas together. Yesterday, we were able to streamline the process a little bit. Once we set up our area, we realized, hey, these all have the same width. We can maybe factor that out and save us a little bit of time. So we're going to be obnoxious again the first time we set up a problem until we see the pattern in our trapezoids and what we can do to maybe shorten this process a little bit. So I'll have you grab your foldable once you are done writing this, because we're going to do that fourth problem on our foldable. Okay, so on the inside of that fourth flap, if you want to write that, what was it? It was N4. N was 4. And so our delta X was B over A over N, which gave us 1/2. So now what we are doing is, so if you go to your graph, okay, we're taking from 0 to 1/2, and we're finding the y values at each to make a trapezoid. From 1/2 to 1, we're finding the values at each, and we're making a trapezoid. From 1 to 3/2, we're finding the y values at each, and we're making a trapezoid. So here we're a little bit of an over approximation because of the concavity and the increasing. And then from 3/2 to 2, oh geez, there's our trapezoid. Not beautifully drawn, but you get it. So I want you to visually see how much more accurate we're going to be with these trapezoids because of their shape. Those rectangles really hung out or in, depending on which way we were going, to our curve. Here we're taking that rectangle and almost forming it a little bit better to our shape. Okay? And once again, the more trapezoids we have, the more accurate we're going to be. Okay? This is a quasi-decent amount, but if we increase it, it gets more tedious, but it gets more accurate. Okay? So I'm going to be a little bit obnoxious at first in how we set this up, and then we're going to look for some patterns. Okay? So we have 4 trapezoids to find. This first trapezoid, that goes from 0 to 1/2. Okay? The area would be 1/2 times delta X times the sum of our bases. We get those from the function height. So one base is at 0 and one base is delta X later. So we have the function value at 0 plus the function value at 1/2. So that's that one. I'll just color it in so we remember that that's what we did. And I know this is obnoxious, just trust the process, okay? 1/2 times height times the sum of the bases. So we have 1/2. The height of our next trapezoid is also 1/2. And then when we talk about the 2 bases of the second trapezoid, this trapezoid is stretching from 1/2 to 1. So our first base is at 1/2, and our second base is delta X later. Our next trapezoid, 1/2 times the height times, now this third trapezoid goes from 1 to 3/2. So our base length will be f of 1 and f of 3/2. And then our fourth trapezoid, we would have 1/2 times delta X times our fourth trapezoid goes from 3/2 to 2. So our first base is at 3/2, our second base is at 2. Okay, you really don't want to have to do that every time. Now, if delta X is not consistent for some reason, if delta X changes from trapezoid to trapezoid, you have to do that. I'll explain to you a case where that could happen here after a while. But since delta x is the same, let's make this easier on us, right? What do all of them have out in front? They all have 1/2, right? They all have 1/2 times 1/2 because it's delta x, right? So if we factor those out, then we're left with f of 0 plus 2 f of 1/2. Oops, that's a 2. Plus, we have 2 f of 1s and 2 f of 3/2, and then just 1 f of 2. Explain to me what's happening in here. Why do I have 2 of some and 1 of others?
I mean, they're gonna happen twice because like 3 houses, the right side of one and the left side of the other.
Okay, so any of these bases that I have in red are a base for 2 different trapezoids, so we're going to have to use them once. So the very left base and the very right base only need to be calculated once, but all of the other bases are a part of 2 trapezoids, so we have to calculate them twice. Now, if we can remember that pattern, we can go straight to setting it up here and then plugging and checking from there. Okay, so now what we have is we have 1/4 times 0 plus 2 times 1/4 plus 2 times 1 plus 2 times 9/4 plus 4. Remember our original equation was x squared. So I'm getting all of those numbers by plugging our x value into x squared. So we end up getting 11/4. Now, I will tell you that the exact area is 2.6 repeating. Which one of those 4 is the closest to 2.6 repeating? Probably the trapezoid. 11/4 is 2.75. Okay. All right, so maybe we should go back to your notes and we should maybe generalize that trapezoidal formula for you. Okay, so our area is going to be 1/2 times the height. And what did we determine the height of all of our trapezoids is going to be? Delta x times, yes, we need our bases. How do we get our bases? Okay. Well, how do I want to write this for you? I'm going to write f of a plus 2 times our next base plus 2 times our next base all the way until we get to B. We use the very left of our interval. We use the very right of our interval. So if you have 5 trapezoids, you're going to have 6 numbers added together in here because we have to start on the right and end on the left. Do you see what I mean by that? Okay. In the pink one that we just did, we had 4 trapezoids, but we had 5 numbers inside that we added together. All right, so we are going to do one more example, and then I want to show you a little bit. Nope, that's not right. This is the example I want to do. We're going to do something a little bit different to get you ready for your worksheet. Yes, you have a worksheet today. Okay, so go ahead and write down this example. The area under the curve y equals x squared plus 1 with 6 subintervals. 6 subintervals. Ooh, we're getting really accurate here. 6 subintervals from 1 to 2. Those are some very small factors. All right. Delta x. Oh, I was going to give you some time to process, but it seems you already have done that. 1/6 would be our delta x. 2 minus 1 over 6. Okay, so if we are doing trapezoids, we have 1/2 times delta x, that's the height. And since delta x is consistent, we can keep this all factored out. Now we have to figure out our bases. All right? Our intervals from 1 to 2. So we will begin with our base f of 1. And then we are going to have 2 at our next base, of our next base. Where does it occur with x values? 7/6, because we have to go 1/6 later. And then we have 2 bases 1/6 later. And then we have 2 bases 1/6 later. I know these aren't reduced, I don't really care. And then we have 2 1/6 later. Oh, can I squeeze it in? And 2 1/6 later. And since now I'm getting to the end of our interval, I only have one of our very last base at f of 2. Okay, so we have 6 trapezoids, but I have 7 numbers inside. But the first and last one, there's only one of. All of the ones in the middle, there's 2 of. So let's divide and conquer here. Pod 1, go ahead and find me these first 2. So this is pod 1. Find me those values. Pod 3. Find me this one. Pod 4. Find me these 2. And pod. Nope, I'm just not divvying out enough. No. Pod 5, you get that one. Nope, pod 4. So this is pod 1, pod 3, pod 4, pod 5, pod 6, you get the last one. Okay? X squared plus 1. Give them to me as fractions, it's easier for us to write down. Okay, so we have 1/12 times, what is f of 1?
2.
And then f of 7/6. What? 36. Okay. F of 8/6. F of 9/6. Would you get 13/4. F of 10/6. of 11/6. Yep. And then f of 2. So we end up with 721 316ths, but you can go ahead and just say this is 3.338. What I don't want you to do is round in here and then round at the end again. It's easier to keep these as fractions and then add them together at the end, and if you approximate, that's fine. But as you are copying that down and writing down your answers, I want to remind you that Tuesday is a quiz. It got bumped to Tuesday, which is nice because we'll have a Monday review day for a Tuesday quiz as opposed to what was going to happen at the beginning of the week, having it Friday, Monday. But I do want to talk about one thing, a couple things from your worksheet. I don't really like, so Mr. Griegel and I use the same worksheets. He typed this one up. What's at the very top, that's not really what I had you write down. I had you write down 1/2 times delta x. That's the same thing as what he has on this worksheet. We just wrote it differently. So if you want it to look like your notes, you can change it to be 1/2 times delta x. That's the way that we wrote it today in our notes. Okay? But I want you to turn it over to the back once you have it the way that you want it to look. And I want you to look at the very, number 5. Okay, number 5, I'm asking you to find the approximation from a table of values. Okay, this actually makes it easier. Okay, but this is what I would encourage you to do. So look up here at this example. I have an interval from 0 to 3, and I'm asking for 3 rectangles. Okay, so I would visually draw out where those rectangles are. So I'd have a rectangle from 0 to 1, from 1 to 2, and from 2 to 3. So if I'm using left-hand endpoints, I would use the numbers 2, 4, 2, 6, and 4 for my heights. But if I'm using right-hand endpoints, then I would use the numbers 6, 4, and 5 for my heights. You see where I'm getting those numbers from? Okay. It makes your job easier, but I would at least make like these bars so you can see what's on the left, what's in the middle, and what's on the right of your rectangular trapezoid. Okay. Number 6, I will have the answer but no work to on my website. Okay, that's kind of the. I don't want to call it a bonus problem because that's not what it is. I want you all to try it, but it's okay if you don't get to my answer. Okay. All other work will be on my website for you to check. So please check your work and your answers with my team. Okay. What questions do you have? I didn't sign very many junior sheets, so I'm guessing you'll have those for me Monday.
Yes.
Okay. Enjoy your weekend. Make good choices. Good luck to all of you competing. There's a variety of you. Sports, show choir.